Okay, this is part 4 of the geometry set of videos for Math 107. So we have volume of geometric solids. The definition is the flat side of a three-dimensional figure is called a face. Polyhedrons are shapes that have 4 or more faces, each one being a polygon. These include cubes, prisms, and pyramids. So we're going to first look at solids with a rectangular base. So these are common polyhedrons in their volume. So a cube, you're probably very familiar with. We would have all the sides equal. So they're congruent squares as bases, all the same size. So volume, we can just do side times side times side, which would be sides cubed. Rectangular prism, we have 3 pairs of congruent rectangular parallel faces. So you can kind of see this face is congruent to this one over here that I'm marking up. Then we have the bottom and the top, and then we have these sides. Okay, so that's our 3 pairs, and it's called a rectangular prism, or like a box shape, typical that you would see. And volume is length times width times height. Now make sure the units are in cubic units, because whatever the units are, if they're inches, we would have inches times inches gives us a base of inches cubed. And again, you don't cube your answer, you're just multiplying out the values that you have here. But the units get cubed. And then a pyramid is a polygonal base right here of a triangular faces that meet at a point. So here's my triangular faces. I have 4 of them. And my volume would be 1/3 length times width times height. Okay, so it's just a 1/3 of what we would have for the rectangular prism. So here's your note here. Make sure volume is always in cubic units. That's really important. So I'm going to look at example 6.16. Find the volume of a cube with side lengths of 6 meters. Actually, I'll just pull this down so you can see the formulas again. You might want to jot those down on an index card or something, but the volume of the cube is just side cube. So go ahead and try that one. You're going to take whatever the side is that's given and put it into the formula and make sure you write out your answer properly with the correct units. So here we have volume equals 6 cubed equals 216 cubic meters, or you could have written it as 216 m with a exponent of 3 to notate that. So now the next one, again, we're just going to plug in to our formula, right? So our formula for volume of this shape here, we're going to have V equals 1/3 LWH, length times width times height. So we're given all those dimensions. So this dashed line here, that's our height, is 8. And our length is 4. And our width is 3. Now if you mix up the length and width, that's okay, but it doesn't really matter which is which. So we would then plug in 1/3, our length 4, width is 3, and height is 8. So just pop that into the formula and crunch the numbers. That's what, you know, a lot of this is when they're just straightforward. And it's cubic feet, or you could do feet cubed, right? That would be fine too. Now, some of these are going to have be a little more complicated because they're going to have missing pieces, just like we looked at in some of the other videos. Now here's a couple more more straightforward problems. We have a cylinder, pair of circular parallel bases right here. So that's my surface area of the top and bottom of the shape there, and then it's like as if it you know, stretches all the way down, right? And that's multiplied by whatever that height is. So you can see how the height is represented here with the radius at a 90-degree angle. And a cone is kind of similar setup. You have that height dropping to the center of your circle at a 90-degree angle, but you just have one base and then the sides go up to a point in a cone, like an ice cream cone. That one's upside down, ice cream cone. So now we're going to look at this, find the volume of a shape shown below. And this is a cylinder. So just use the formula up here. Do this one as a classwork. So you're going to pause, complete, and check. And I won't have the full answer in there, but I'll just have what the answer is. Actually, this one was pretty short. So just getting the setup, pop in your values. This 1.5 pi meters squared is the exact answer. And then when we round off, we're going to use this approximation symbol here and get 4.71 cubic meters. Next, we're going to look at the sphere and its volume. So a sphere is a single circle rotated 360 degrees. So it's just filling all that space like a ball. And the volume would be V equals 4/3 pi r cubed. So as long as you know what the values are, you can pop it in there. It's when we have missing pieces that these get challenging, or if you are putting parts together. So if you have like the snow cone or something like that, sometimes you need to consider half a sphere plus a cone and that sort. So for this one, we're gonna just plug in, write down the formula, right, and then plug in. So our radius is given as 3. So V equals 4/3 pi and then 3 cubed. You can go ahead and calculate that. Okay, so that gives us 4/3 pi, and 3 cubed is going to be 27. And we'll go ahead and crunch those numbers. And what we can do here, we can actually reduce this. We can have 3 into 3 is 1, 3 into 27 is 9. You could have used your exponent laws too, if you wanted, because we have like bases here. And so my volume is going to be 36 pi, and that's in centimeters cubed. Or we could approximate. Usually for word problems in this course, you're going to do approximated answers as decimals. So we would have, just going to round off to 113 cubic centimeters. I'm just using either form for you. That would be the volume of this sphere. So one more problem, and I'm going to have you do that as a classwork, so you can pause and then, check. Pause, complete, and check. And this one does have some missing pieces. One of the things is the height for the cone. So you need to figure that out. However, we did a problem like that in one of the other videos using Pythagorean Theorem. It was just the same exact dimension. So for my Pythagorean theorem, I'm going to use just the radius part. So I would have my use a squared plus b squared equals c squared to find height. And then you're just going to do a half of a sphere. So just to set you up with that, to get the volume of the half sphere, you're going to just use the same formula as sphere, but just cut it in half. So it would be 1/2 times 4/3 pi r cubed. Your r is 2. So just plug that all in and figure out what that's going to be. And then you're going to add that to your volume for the other piece. The whole cone here would be the other. Here, I'll mark that out. The pink is your whole cone. Okay, so volume of cone is going to be 1/3 pi r squared times height, and you have to figure out your height from here and pop it in, okay? Then you're going to add those together. So the total volume equals the sum of half sphere, area, half sphere, and area, not area, volume. Sorry. The volume of the half sphere and volume of the cone. So go ahead and try that. I'll write it out here and then kind of talk through it real quick. Okay, so here's the answer for this. We had talked about the formulas here that you're going to use. And for the total volume, we're just going to add the volume of the half square plus the volume of the cone. So I just wrote it all in one line here, which you can do. That's a nice technique. Just fill in the volume, the info for the volume of the half sphere. So then I got 16.76 for that once I crunched my numbers. And then for the cone, I got 23.71. Now, one thing I want to note too, for the cone, I am just using the 2, unlike I did before when I was using it was an area formula. So I was getting like the area of this, you know, of a triangle, and I needed the entire base across. But here you notice the volume of a cone formula has radius squared there. So that's different. It's a different technique you're using. So we have 23.71. The Pythagorean Theorem, I got my height same way I did with the triangle though, and that came out to 5.66. You can look back at the steps for that if you need them. Total volume comes out to be 40.48 cubic feet. Sometimes I ask you to round a couple places, sometimes just to the nearest whole number. So it depends. So I'm just kind of mixing up how I do that. So your instructions should be specific in My Open Math or on a test. If it's not, in general, just go 2 places out. So that is it for the geometry lessons. There's one additional video that has a good problem on it, another example from another instructor if you're interested in that as well. But you don't have to do that one for notes. So have a great day and let me know if you have any questions.